Welcome to the shop. Today we're talking voltage drop. Common method that I use to troubleshoot circuits that are having trouble. We've got set up here my favorite load of choice, the 1400 watt Milwaukee heat gun. I like this guy because it's nice and quiet. So we'll be starting out there. This outlet to make sure this guy works. Yeah, seems to be working. Good. So let's see what kind of voltage we're getting here. In this circuit here, we're sitting at 116.6, 117. Okay, so that's good voltage. Now, the normal call I get is, hey, my outlet doesn't work, and then I show up and use the Pixie Sticks, and it tells me, hey, 117 volts. Hey, we got good voltage there. Everything seems to be okay. But then you plug in a load, and it doesn't work. Now let's show you a way that that could happen. We've got 3 different wire gauges to simulate different circuits here. We've got a 10 gauge wire, a 12 gauge wire, and a 14 gauge wire. We're going to see what happens to the voltages on each one when we run this guy through 250 feet of each of these kinds of wire. Starting with our 14 gauge wire. Let's get that plugged in there. Let's get the meter plugged in there. Plugged in there. Ah, there. Okay, there we go. We got our 116.9. That's our starting voltage. Now we load this thing down with 1400 watts. And what happens? Drops down to 100 volts. 100 volts is no good. Now the code says that we don't want any more than 3% drop on a circuit. We got a 120 volt circuit, that's 3.6 volts. So we don't want it dropping below, say, 113. But this is pulling this thing down to 101. We got 101.1. So that's no good. So if we were troubleshooting this would be an actual problem we'd have to find and figure out why it's dropping so low. Right now we know it's because we got 250 feet of 14 gauge wire, and that's just way too long. The actual resistance in the wire is creating that voltage drop. So let's try it on some 12 gauge, right? Take that, plug it into our 12. We're gonna move the meter, wiggle, wiggle. Good. I'm gonna move our meter over here. There we go. Okay, 117.5. It's our starting voltage. Kick it on, engage, and we're at 105. 105.5 volts. So that thicker wire has less resistance, so there's not as much voltage drop. But 105 is still no good. Definitely you never want to be below 110 volts. Most equipment designed to run on between 110 and 130 volts nominal. So let's see what happens when we step the gauge up. Okay, we're back at that 117.5. That's good. Same starting voltage. Alright. Got our heater gun plugged in. Contact. Ooh, looks like 108. That puts us at 108 volts, almost. So that's 250 feet at number 10. Dropping almost 10 volts. Which is why a wire gauge is important, and also the circuit length is important. And also, when you're using extension cords for heavy tools, you want thicker gauge extension cord, even though it's more expensive. Smaller extension cord is no good. You're gonna cause connections to burn up. So now let's go all out, right? We got 3 rolls at 250 feet. If we add 2 of them, let's say we add, let's take 12 gauge, plug it into 14 gauge. So now we've got power running through our 14 gauge wire out into our 12 gauge wire. And we're gonna see what the voltage is at. Should be the same starting voltage, nothing's changed. So we should have that same like 117.5, 117 something. 117.5, good, good. Through 500 feet of wire. Here we go. Oh, smart. Probably gotta actually be plugged into what we're testing, huh? That'd be good. Yeah. Okay, try that again. 500 feet of wire, here we go. Boom! 94. So we're down at 94.7. 94.7 volts, so it looks like we're getting the lights to do a little flicker. Try it again. Oh, yep. 94.8. Yeah, I don't recommend doing this to any of your actual stuff at home. Running this stuff on under voltage condition is not great for the equipment. So let's go 750 feet. So that means we got power running through our 14 gauge, running through our 12 gauge. And then, twisting, we're gonna run it through our 10 gauge. Okay, so now this is our power outlet through 750 feet of wire. Okay, we're at 117.1, 117, something like that here. Close enough, right? Let's see what this does. On. Whoa, that sounds like it's struggling. Ooh, this does not like that. We're running on 90 volts. Just 30 volts shy of 120 volts. Not nearly enough to do really anything with. Back down, yep, 90 volts. Yikes. So let's take all that apart. Take that apart. And take that apart. Good, good. So, once again, if you're dealing with an outlet at home that doesn't seem to be working quite right, but it's still got power to it, test it with a voltage drop test. Take a load, it could be a vacuum, could be a power tool, something that draws a lot of power, right? figure out what your starting voltage is with a meter, a proper meter. This meter, make sure your connections are good. This meter showing us 117. We're looking for no more than 3% voltage drop. And we're down to 100 volts. Now I know there's a problem somewhere. Could be the length of wire, like we know now, but in a regular home it's going to be something like a corroded connection, maybe a loose connection at a breaker, a plug that's burned up somewhere in the circuit. Some sort of problem causing that voltage to drop so much when it normally wasn't dropping like that. And once again, boom, 100. 100's no good. We're looking for something more like this scenario coming right out of the wall. Cram the meter, go in there, back to 117, plug in direct into the circuit, drops down to 113. That dropped 4 volts, and wow, that's running a lot better. I can hear that. It's running a lot healthier. And that shows us that this circuit is perfectly okay.